Good morning, y'all. I want to start this video by asking you to think about the last 10 days. Think about what the weather has looked like across the south central United States over the past week and a half. Maybe you were outside more than usual. Maybe you ran errands without checking the radar first. Maybe you let your kids play in the yard in the evenings without a second thought about what was building on the western horizon. Maybe, and this is the part that matters most, you got a little comfortable. And I understand that completely, because when the atmosphere gives you a break, even a short one, human nature is to relax into it, to stop thinking about shelter plans and warning apps and phone chargers, to just breathe. That is human, that is normal. But here's what I need you to understand this morning, and I need you to understand it before you do anything else today. The atmosphere was not relaxing with you. While the surface pattern across the southern plains stayed relatively quiet, and a series of clipper systems kept the action locked up north of the border, something was building. Something was loading. Something was being assembled on the other side of the Rockies that has been growing in size and intensity and organization for days. And now it is almost here. The break is over. Severe weather is coming back to the south central United States. And when it arrives, it is not going to arrive quietly. Let me explain the meteorological reason for this break first, because I think understanding why the last week or so has been quiet is the key to understanding why the return is going to be so sudden and so dramatic. The pattern that has been dominating the country since early April has been what forecasters call a positively tilted trough regime. In simple terms, that means the waves of energy moving through the jet stream have been oriented in a way that sends storm systems rapidly northward and eastward, up into Canada, out over the Great Lakes, and away from the warm, moist air mass that sits over the Gulf of Mexico and the southern plains. That kind of pattern is efficient at producing storms across the northern tier of the country, but it starves the southern plains of the dynamic, forcing its needs to ignite severe weather. The warm, moist air was sitting there. The Gulf was pumping moisture northward. The fuel was ready, but there was no match. No deep, organized trough digging far enough south to tap into all of that energy and set it off. And so the atmosphere sat, deceptively quiet, while the Gulf continued to pump warmth and moisture northward, and the instability continued to build quietly underneath the surface of a pattern that looked calm from the outside. That is what a meteorologist means when they say the atmosphere is loading. Not that storms are happening. That the ingredients for storms are accumulating in silence, waiting for the trigger that has not arrived yet. That trigger is now arriving. And it is not subtle. What is arriving from the west right now is a fundamentally different kind of upper-level system than what we have been dealing with over the past several days. Instead of a positively tilted, fast-moving wave that races through and exits quickly, what is digging into the western United States right now is a negatively tilted, amplifying upper-level trough. One that is slowing down, deepening, and orienting itself in exactly the configuration that produces the most violent, severe weather outcomes across the south-central United States. The distinction between positively and negatively tilted troughs matters enormously in severe weather forecasting, and I want to explain it clearly because I think it unlocks why this return is going to be so dramatic, rather than just another routine spring severe weather event. A positively tilted trough moves quickly, exits fast, and does not give the atmosphere time to fully destabilize before the cold air rushes in and shuts the party down. A negatively tilted trough slows down. It wraps cold air aloft around its base. It drives surface lows to explosive depths as it approaches the plains. And most critically, it spends time over the same region, allowing the atmosphere underneath it to build to full potential before the first storms even fire. The negatively tilted trough is the atmospheric equivalent of opening the oven door all the way. Everything inside gets exposed to maximum heat simultaneously, and the result is violent and fast. That is what is arriving. That is why the return is going to be dramatic. Now let me get into the specific atmospheric ingredients that are coming together for this event, because the numbers matter and I want y'all to have them. The precipitable water values, the total column moisture content of the atmosphere ahead of this incoming trough are running at 150 to 200% of normal for mid-April across the corridor from the Gulf Coast northward through Texas and Oklahoma into southern Kansas. Let me translate that percentage into something you can feel physically. Normal precipitable water for this region in mid-April runs around 1 to 1.25 inches of water vapor in the atmospheric column. We are forecast to see 1.5 to 2.5 inches ahead of this system. That is not just above average. That is the kind of moisture loading that makes the atmosphere feel different when you walk outside. The air is thick, it is heavy. It presses against you with a humidity that belongs in late June, not mid-April. That moisture is the fuel. And when the negatively tilted trough arrives and begins forcing that fuel-laden air mass upward, the CAPE values, the convective available potential energy, that result are going to be exceptional. Multiple model solutions are generating peak CAPE values of 2,500 to 3,500 joules per kilogram in the highest overlap zone across central Oklahoma, northeastern Texas, and into southeastern Kansas. Anything above 1,500 joules is significant for severe weather. Anything above 3,000 joules is extreme. We are forecast to be at 2.5 to 3.5 times the threshold for significant severe weather in the best corridor. Layer on top of that the wind shear environment, which is the ingredient that determines what kind of storms form in an unstable environment and how dangerous they become. The critical distinction in severe weather forecasting is always between an environment with high CAPE and low shear, which produces pulse thunderstorms that dump rain and move on without much organization, and an environment with high CAPE and high shear, which produces the rotating, persistent, violent supercell thunderstorms that generate significant tornadoes and extreme hail. What is setting up with this return of severe weather is unambiguously the second category. The directional wind shear in the lowest levels of the atmosphere is going to be extraordinary as the surface low deepens and the pressure gradient tightens ahead of the trough. Surface winds across the warm sector are forecast to back to south-southeasterly at 15 to 25 miles per hour, while winds at 5,000 feet veer to southwesterly at 40 to 50 miles per hour, and winds at the jet stream level reach 120 to 140 miles per hour from the west-northwest. That progression, southerly at the surface to west-northwesterly at the jet stream, increasing in speed by nearly 10 times over less than 30,000 feet of altitude, is the textbook recipe for the most dangerous kind of storm-relative helicity. The helicity values being generated by that profile are running at 300 to 450 meters squared per second squared across the primary threat corridor. 300 to 450. The threshold for significant tornado potential is 150. The threshold for violent long-track tornadoes is generally considered to be 300 and above. We are forecast to exceed the violent tornado threshold across a broad corridor. That is what dramatic means in the context of this return. The geographic area I want y'all to focus on most specifically. The corridor where the combination of extreme instability, dangerous helicity, and the deepest surface low track is going to produce the highest severe weather potential. Runs from north-central Texas through the heart of Oklahoma and into southern and eastern Kansas. Within that corridor, the sub-areas I am watching with the greatest concern are the Red River Valley region along the Texas-Oklahoma border, the Oklahoma City metropolitan area, and the communities south and east of it, the Tulsa Metro and northeastern Oklahoma, and the southeastern Kansas communities around Chanute, Independence, and Coffeyville. These are communities that sit directly in the path of what the models are depicting as the highest overlap zone of extreme CAPE, violent helicity, and the strongest wind shear, the three-legged stool that produces the most dangerous supercell thunderstorms. If you are in any of these communities, I'm talking to you specifically right now, not generally, not as part of a broad regional audience. Directly to you. Your preparation for this event needs to happen today, not the morning storms are on the radar. I need to spend time talking about the dry line because it is one of the most important and most underexplained elements of this entire setup. And I think understanding it helps you understand the explosive nature of the convective initiation we are expecting. A dry line is a boundary that develops across the southern plains in late afternoon when the dry, hot air flowing eastward off the high terrain of New Mexico and West Texas collides with the warm, moist air streaming northward from the Gulf. On one side of the dry line, the western side, the air is hot and dry with dew points that can be in the 40s and 50s. On the other side, the eastern side, facing the Gulf, the air is warm and saturated with dew points in the 60s and 70s. That boundary, when it is sharp and well-defined, and when it is intersecting a region with a deep capping inversion that has been suppressing storm development all day, becomes the most efficient thunderstorm initiating mechanism in North America. Here's why. The dry line provides the differential lifting needed to punch through the cap. The cap, that layer of warm air in the mid-levels that has been acting like a lid on a pressure cooker all day, holding back the instability that has been building and building underneath it, finally breaks along the dry line in the late afternoon as surface heating reaches its maximum. And when it breaks, it does not break gradually. It breaks at once. All the instability that has been stored under that cap since sunrise releases simultaneously along the dry line, and thunderstorms do not gradually develop. They explode. Within 30 to 45 minutes of initiation, you can go from no storms on the radar to violent rotating supercells generating tornado warnings. That is the nature of a capped, dryline initiated severe weather day. And that is exactly the nature of what is coming. The overnight threat from this return of severe weather is something I want to address head on, because it is the part of this event that has the highest potential to catch people off guard. The supercell phase, The discrete, organized, violent, rotating storms is expected to develop during the afternoon hours of the peak event day, likely between 2 and 5 in the afternoon local time. But those supercells do not simply stop when the sun goes down. They continue eastward, some of them reorganizing into squall lines, others maintaining their supercell structure well into the night, carrying their tornado and hail threats into communities in eastern Oklahoma, western Arkansas, and potentially into the Missouri Ozarks during the late evening and overnight hours. The squall line that consolidates out of the earlier supercell activity is forecast to push through the Arkansas River Valley and into the Tennessee and Ohio valleys during the overnight window, somewhere in the 10 at night through 4 in the morning time frame for the most intense embedded mesovortices and organized bowing segments. I have said it before, and I will say it every single time a setup like this appears on my radar. Overnight tornado events kill people who would have survived if they had been awake. Full stop. Not because the warnings are not issued. Not because the warning systems fail, but because people are asleep, and asleep people do not hear outdoor sirens, do not see push notifications, and do not feel a phone vibrate on a nightstand set to silent. Y'all Call exists for exactly this reason. When a tornado warning polygon issued by the National Weather Service covers the GPS coordinates of your phone, Y'all Call calls you. It rings your phone the way a phone call rings, persistently, loudly, cutting through do not disturb and sleep mode with the kind of urgency that no notification can match. $14.95 for a full year of protection. The link is in the description of this video. Please use it before tonight. Please use it before this event's overnight window opens, because by then it will be too late to set it up. The hail threat from this return of severe weather deserves specific discussion, because it is going to be one of the most widespread property damage producers of this entire event. When you have KP values of 2,500 to 3,500 joules per kilogram and cold upper. Level temperatures, driven by the negatively tilted trough, sitting at negative 45 to negative 55 degrees Celsius at the 500 millibar level, you have created the ideal factory for very large hail growth. The updrafts inside the strongest supercells associated with this setup are going to be violent. When you have that much instability concentrated in an environment with that steep elapse rate, updraft velocities inside the storm cores can exceed 150 miles per hour. Hailstones that get caught in those updrafts cycle up and down dozens of times, each cycle adding a new layer of ice, growing to sizes that would be nearly unimaginable to someone who has never experienced a major plains severe weather event. In the strongest cores associated with this setup, I think baseball-sized hail is not just possible, but likely. 2 3/4 inches. That is the size of a small apple, traveling at 50 to 60 miles per hour. I want y'all to sit with the practical reality of that for a moment. It will destroy the windshield of your vehicle. It will punch through the panels of your roof. It will strip every leaf and small branch from every tree in its path. It will put anyone caught outdoors in a genuinely dangerous situation within seconds. A severe thunderstorm warning this week is not a casual watch it from the porch warning. It is a get inside immediately warning. Every time. The flash flooding component of this return of severe weather is also going to be significant, and it is the hazard that has the broadest potential geographic footprint. The combination of exceptional precipitable water values, 1.5 to 2.5 inches, compared to a mid-April normal of around 1 inch, with the training thunderstorm potential behind the initial dry line initiation, is going to produce rainfall totals in some areas that are going to be impressive and dangerous. When storms develop along a dry line and then subsequent cells keep forming at nearly the same initiation point and tracking in nearly the same direction as the first cells, you get a training pattern where the same communities see round after round of heavy rainfall in a compressed time window. Rainfall rates of 1 to 2 inches per hour inside the cores of the strongest cells are entirely plausible in this moisture environment. And if that training pattern sets up over the same community for 3 or 4 hours, the resulting totals of 4 to 6 inches in a 6-hour period will produce flash flooding that moves fast and gives very little warning. The areas most vulnerable to that training flash flood scenario are the creek and river systems of north central Texas, eastern Oklahoma, and the Arkansas River Basin. If you are in low-lying areas or near any drainage system in these regions, watch the water this week. Watch it from the moment the first storms initiate. And if any road in front of you has water crossing it, any road, any amount of water, turn around. Do not drive through it. There's no amount of urgency or schedule or inconvenience that is worth what happens when a vehicle is swept off a road by moving floodwater. Turn around every single time. Here's what I want you to take away from this video, because in the end, information only saves lives when it translates into specific actions. The atmosphere that has been relatively quiet across the southern plains for the past several days was not healing, it was loading. The Gulf was pumping moisture northward the entire time. The instability was building the entire time. And The negatively tilted trough that is now arriving from the west is the match being dropped into that very dry, very loaded room. The return of severe weather this week is going to be dramatic. Not because I want drama, but because the physics of what is assembling leave very little room for any other outcome. So here is your action list. Share this video right now with everyone you know in Texas, Oklahoma, Kansas, and Arkansas. Set up Y'all Call Today. The link is in the description. It takes 5 minutes, and it could be the most important 5 minutes you spend a day. Walk to your shelter and verify it is accessible, uncluttered, and reachable in 30 seconds in total darkness. Charge every device in your home. Pick up a backup power bank if you do not have one. And mentally commit to staying engaged with the weather through the duration of this event. Not just the first couple of hours of the afternoon, but through the evening and through the overnight hours, because that is when the danger is often highest and awareness is lowest. I'm going live the moment the first storms initiate, and I'm not signing off until every watch has expired and every community is safely on the other side of this return. Subscribe to this channel, hit the notification bell, and I will see you all in the live stream. Stay safe out there. I love every single one of you.